Let's start with the percentage composition. In this, we are going to solve around 8 questions of different kind. Pause the video, read the question. I'm going to solve the problem. A. You have to find percentage of carbon in carbon dioxide. First step, find the molecular mass of carbon dioxide. Simple, add the atomic masses. One carbon atom, atomic masses will be provided. 12 plus 2 oxygen atoms, 16 into 2, 32. So you should get 44. Similarly, find for sodium carbonate and aluminum nitride. Sodium carbonate 106, aluminum nitride 41. Next, percentage, how do you find? Total mass of the element divided by molecular weight of the compound into 100. So there is only one atom of carbon, so 12 by 44 into 100, 27.3%. Similarly, percentage of sodium, there are two atoms, so 23 into 2, 46 you have to take. Molecular weight is 106 and solve it, 43.4%. Aluminium nitride, only one aluminum atom, so 27 by 41 into 100, 65.85%. Question number 2, read the question. Similar kind of question. You first find the molecular weight of K3FeCN6. Be careful here. When you write in bracket Cn, this 6 is applicable to both. So it will be C6 and N6. So I have done it step by step. 3 atoms of potassium, 3 into 39 plus iron 56 plus. I kept 6 here into the carbon is 12 plus nitrogen is 14. So 6 into 12 plus 14. Okay, when you solve this, you will get around 329. Remember molecular weight, or if you're finding the relative molecular mass, express it in AMU or just write a number. If they ask you to find the gram molecular mass, just write grams in front of this. The next step is to find the percentage of iron. So simple, only one atom of iron is there, 56 by 329 into 100, 17.02% of iron. Next question. Read the question. They are asking, out of these two, which has the higher percentage of nitrogen? Same way, first you find percentage of nitrogen in calcium nitrate and then ammonium sulfate. Then you, whichever is higher, that you will say that it has higher percentage. So calcium nitrate, you should get 164, and for ammonium sulfate you should get 132. Then finally, percentage, how you will find in both the cases? Percentage of nitrogen 28 by 164, 28 by 132 here. So for calcium nitrate you are getting 17.07, for ammonium sulfate 21.21. so therefore ammonium sulfate contains higher percentage of nitrogen. Next, calculate the percentage of pure aluminum in 10 kg of aluminum oxide of 90% purity. It is important to understand the question. They have given 10 kg of Al2O3, but they are telling that 90% of it only is pure. So basically, if you take 10 kg of aluminum oxide, 90% is pure aluminum oxide, means only 9 kg is pure aluminum oxide out of 10 kg, and remaining 1 kg is what? Some impurity. First, let's find what is the percentage of aluminum in 100% aluminum oxide. So molecular weight of aluminum need to find, same way, do step by step, then you will get 1 or 2 AMU. Therefore, if you calculate 1 or 2 grams of aluminum oxide will contain 4 gram of aluminum, right? 2 atoms. Therefore, 9 kg or 9000 grams of aluminum oxide will contain how much? 54 into 9000 by 102. You will get 4.764 kg or 4764 grams. See, this is the amount of pure aluminum. Even if you take 9 kg or whatever they have given here, 10 kg, because in the remaining 1 kg there is nothing, there is no aluminum oxide. Basically in 10 kg itself you will have 4.76 kg of pure aluminum. So therefore you have to find the percentage. 10 kg of aluminum oxide, 4.76 kg of pure aluminum is there. 100 gram of aluminum oxide, how much? Simple calculation, you will get 47.6% pure aluminum. Pause the video, read the question. Again, similar question what we did earlier. Just find the percentage of potassium in both potassium phosphate and potassium nitrate. Then find whichever is higher percentage, that will be the better fertilizer. Same thing for ammonium phosphate and urea, whichever has higher percentage of nitrogen, that will be the better fertilizer. Here there is a typo. Calculate the percentage of carbon in a 55% pure sample of calcium carbonate. It's not carbon carbonate, it is calcium, because the calcium atomic mass given here. Simple again. First find the molecular weight of calcium carbonate. So when you solve it, you will get 100 AMU. Then in that, what is the percentage of carbon? 12 by 100 into 100 means 12%. Okay. It is for, if you take 100% calcium carbonate, you will get 12% of carbon in that. But they have given 55% pure sample. So therefore, in 55% pure calcium carbonate, percentage of carbon will be 55 into 12 by 100 is equal to, when you solve it, you will get 6.6%. So that is the answer given. Seventh question. Calculate the percentage of water of crystallization in hydrated copper sulfate, CuSO4.5H2O. It is also called as blue vitriol. Simple. First find the molecular weight. What you will get when you solve it step by step. Here, take 5 into molecular mass of H2O, 5 into 18. So you will solve it, you will get 90. So it is important because there is 90 gram or 90 into 49.5, right? Therefore, then how do you solve this? Percentage of water is, it is 90 into 49, therefore in 100 how much? 36.07%. Simple. Okay, this is interesting question. Read the question carefully. They have given hydrated calcium sulfate, formula also given, CaSO4.xH2O. X means how many water molecules are there, number. Contains 21% of water of crystallization. Okay, calculate the number of molecules of water crystallization. That is, you have to find the X. Everything is given. First, let's find the molecular weight. Molecular weight of CaSO4.xH2O. When you solve this, calcium sulfate, you will get 136. XH2, how you will get? 18, and keep X as such. So, the molecular weight, you will get 136 plus 18X. Right. Next, percentage is given. So, solve for the percentage. So, percentage of water given is 21%. So, simple calculation, what do you do? Percentage is equal to total mass of the compound divided by molecular weight into 100. So, 18x is the total mass of water into 100 divided by total molecular weight is 136 plus 18x. So, when you solve this for the x value, okay, 18x into 100 is 1800x plus is equal to 21 into 136 plus 21 into 8 is 18x. Then you solve this, you will get x is equal to 2. So therefore, the number of molecules of water is 2. Next, finding the empirical and molecular formula. Okay, first questions, pause the video, read the question. Percentages are given, carbon and oxygen. Hydrogen, you just have to find 100 minus whatever percentage of carbon plus oxygen. If you do, you will get the hydrogen. Vapor density is given 83. Empirical molecular formula asked. First, you have to put this kind of table: element, percentage composition, atomic mass, atomic ratio, simple ratio. Don't skip any step. Elements are carbon, oxygen, hydrogen. Percentages already given, atomic masses will be given. So first 3 columns will be given. You have to find only 2 columns. Atomic ratio, how you will find? Whatever percentage composition divided by the atomic mass, 57.82 by 12 for carbon. Similarly for oxygen, whatever percentage divided by 16. Hydrogen, 3.6 by 1 means 3.6. So you will get 4.81, 2.41 and 3.6. Out of the 3 atomic ratios, you have to take the smallest. Out of these 3, 2.41 is the smallest. So to find the simple ratio, you have to divide all the atomic ratio values by that smallest number. So therefore, to 4.81 by 2.41, like that you have to do for all. So when you solve this, you will get carbon 2, oxygen 1, but hydrogen 1.5. When it is 0.5 coming, you cannot round it off. If it is coming 1.1, you can round it off to 1. Okay, 1.9 if it is coming, you can round it off to 2, but 0.5 if it is coming near to 0.5, you cannot round it off. In such cases, the simple ratio should be in whole numbers. So to make it whole number, you have to multiply the simple ratio values by 2. You cannot multiply only hydrogen, you have to multiply all the 3. Then you will get carbon value 2 into 2 is 4, oxygen 2 into 1 2, hydrogen 2 into 1.53. So from this you will get the empirical formula C4H3O2. So from this you can find the empirical weight. Simple, just like you find molecular weight, add the atomic masses, whatever numbers of atoms are there, you will get empirical weight. So it is found to be 83. One more information they have given, vapor density 83. So how do you find from vapor density molecular weight? 2 times vapor density. So 2 into 83 is 166. Next step is to find n. N is what? The number. How do you find molecular weight by empirical weight? Both are already found. 166 by 83 is equal to 2. So molecular formula will be n times empirical formula. N is 2, empirical formula is this. So final answer C8H6O4. So next different kind of question. Pause the video and read the question. So when you read the question, you will understand that there is no percentage composition given and there is no element X. What is it? We don't know. But they have given the atomic mass for X. It is 64. How do you find? To find the empirical formula, you need the percentage. So mass of X is 1.89. Total mass of the compound is 4 gram. So you can find the empirical formula step 1 by find percentage composition of X and Cl. So percentage of X is 1.89 by 4 into 100. You will get 47.25. You can find percentage of chlorine by just 4 minus 1.89, or you can just subtract the percentage of X by 100. You will get 52.75%. Next step is, once you get the percentage composition, again put the table, find the simple ratios. Then you will find that X simple ratio is 1, Cl you are getting 2. So empirical formula is XCl2. So these are the step-by-step methods. Third question, molecular formula of a compound whose empirical formula is CH2O and vapor density is 30. So empirical formula already given, vapor density given, simple molecular weight you find. To find molecular formula, we need N, right? So empirical formula given, vapor density given, molecular formula they have asked. Step 1, to find formula, molecular formula, we need N. So to find N, we need molecular weight and empirical formula weight. So from empirical formula, we will find empirical formula weight, which is 30. Molecular weight is 2 times vapor density. So 2 into 30 is 60. So N will be 2. Therefore, molecular formula will be 2 times CH2O, C2H4O2. Fourth one. Pause the video, read the question. Here they have again given the masses, but not the percentages. Same thing what we did previously. Find the percentage by mass divided by total mass. Total mass is 1.3 gram. Molecular weight given 122. Put the table. Okay. Then find each and every step, same thing. Atomic ratios you will get. Simple ratio, you have to round it off to nearest whole number. So for aluminium 1, phosphorus 1, oxygen you will get 4. Finally, empirical formula is AlPO4. Okay, 2 organic compounds. Pause the video, read the question. They have given carbon and hydrogen. Organic compounds contain carbon and hydrogen only. Vapor densities are given. X and Y. X is 13, Y is 39. They have asked what are the molecular formulas of X and Y. So from the given information, first, from given information, we can write that empirical formula of X and Y is CH, because they have not given any other information, right? So therefore, empirical formula weight will become 12 plus 1, 13. So once you get empirical formula weight, vapor densities are given. So for X, molecular weight will be 2 times 13 vapor density. So that is 26. So N is equal to 2. Therefore, molecular formula is C2H2. For Y, molecular weight is 2 times 39, which is 78. Again, N is 6. Therefore, molecular formula is C6H6. Next question, read. Again, the percentage composition, everything is given. What is the difference here? Calculate its molecular formula assuming that all the hydrogen in the compound is present in combination with oxygen as water of crystallization. So method is same. You will get zinc 1, sulfur 1, oxygen 11, hydrogen 14. So given information, we know that all hydrogen are in water of crystallization. Therefore, we know for 2 hydrogen atom we need 1 oxygen atom. Therefore, water of crystallization is, there are 14 hydrogens, so 7 into 2. So therefore 7H2O. So in that 7 oxygen are gone, so 11 minus 7 means 4 oxygen are left. So we can write empirical formula as ZnSO4.7H2O. A hydrocarbon contains 82.8% of carbon. Find its molecular formula. Again, hydrocarbon means carbon percentage given, hydrogen percentage 100 minus 82.8. Remaining everything same. Okay, so I have already solved this here. Step by step, again put the columns. So here for hydrogen, simple ratio will get 2.5 approximately. Again, you have to make it whole number. So you have to multiply both carbon and hydrogen by 2. So you'll get empirical formula C2H5, right? Then again find N has become 2. So molecular formula will be 2 times C2H5, it is C4H10. Eighth question, read the question here. You just have to change, determine its molecular formula, not empirical formula. Check your text. It is page number 95 and 96 of DALAL series. If the compound contains 12 atoms of carbon. Okay, here percentage of hydrogen oxygen given, you can find the percentage of carbon. So one information they have given, number of carbon atoms are 12. Nothing about molecular weight. That much is enough. So again put the column, find everything. So simple ratio will be for hydrogen 2, oxygen 1, carbon 1. So empirical formula is CH2O. Since they have given the information, number of carbon atoms are 12. So only carbon cannot be 12. So you have to multiply all the three simple ratios by 12. So when you do that, multiply all simple ratio values by 12, molecular formula will be C12H24O12. That will be the answer. Ninth question. Again same, percentages are given. So percentage of water of crystallization, calculate the empirical formula. So again do as per the previous example. Here only one change you can do is, for water don't take hydrogen and oxygen separately. Whatever oxygen is there, you just calculate it. But for water, you take it as a molecule itself. So therefore percentage of water, how you will find 100 minus whatever percentages are given, so you will get 36%. So how do you find the molecular ratio? Previously you find for atomic ratio because they are elements. This is molecule. So 36 by 18 into, if you do that, you will get 2. So therefore when you solve it, okay, you will get empirical formula. When you solve it for all other things, you will find simple ratio for water as, it should be 5. Okay, so you will get 5H2O, CuSO4.5H2O. Next, read the question again. Masses are given, percentages are not given. Same question, similar question, just find percentage of carbon and percentage of hydrogen. So percentage of carbon 0.6 by 0.7 into 100. Percentage of hydrogen 100 minus 85.71, you'll get 40.29. So do as per the solved examples, similar. 11th question, similar question again. Try yourself. Answer they have given here, you can check, or your answer can also become like this, AlKS2O8. So that is also correct because it is empirical formula. Next comes questions based on chemical equations. Okay, pause the video, read the question. Okay, step 1, always for chemical equations related questions, write a balanced equation. Sometimes they will provide, sometimes you have to write. So silver nitrate aqueous, HCl aqueous gives you silver chloride plus HNO3. This all I got from here. What mass of silver chloride will be obtained means silver chloride is in the product side. By adding an excess of hydrochloric acid means hydrochloric acid is a reactant to a solution of 0.34 gram of silver nitrate means silver nitrate is also a reactant. So this is a double decomposition or precipitation. So you can predict one more product HNO3 yourself. So in the red, what I have written, it is what is asked. So for 0.34 gram, what is the mass of AgCl you will get? Always solve these kind of questions like this only. So what you will do, below whatever related, don't worry about HCl and HNO3. AgNO3, find its molecular mass by simple step, right here only, 170 you will get. AgCl again, find, you will get 143.5. So from this information, what you can write is, if you take 170 gram of AgNO3, it will give 143.5 gram of AgCl. Therefore, for 0.34 gram, how much you will get? Simple calculation. So 143.5 into 0.34 by 170, if you do, when you solve this, you should get 0.287 gram of AgCl. Okay, this is the simplest question. Again, similarly, they may ask you sometimes what is the volume of the gas. So read this question. Again, they have not given the equation. KClO3 is a potassium chlorate. Write balanced equation first. Potassium chlorate on decomposition will give you potassium chloride plus oxygen gas. You can predict oxygen gas is there. Okay. So reading, what is asked? 20 gram. If you take 20 gram of KClO3, what is the volume of oxygen you're getting? So first, what is the molecular weight of KClO3? So these two you have to keep as such. In the bracket, you will find the molecular mass of KClO3. It is 122.5 into 2 if you do 245 gram. So here come according to molar volume. We know that any 1 mole of any gas occupies 22.4 liters. But here how many moles? 3 moles. These numbers coefficients also represent moles. So 3 into 22.4 liter at STP. When you solve this, 67.2 liter at STP. So therefore, from this information, what you can write, 245 gram of KClO3 gives 67.2 liters of oxygen at STP. Therefore, 20 gram of KClO3 gives how much? When you solve it, you will get 5.48 liter of oxygen. Simple calculation. Next, third one. Here they have already given you the balanced equation. From that, they have asked to calculate mass of copper needed to react with 63 gram of, then 2. Okay, let's read. First, write the balanced equation. Once again, you have to write it. They have asked first question, what is the mass of copper? Okay, when you take 63 gram of nitric acid, and what is the volume of NO will be released at the same time. So again, same way, copper 3 into atomic mass 64, 192 gram. Similarly, find for HNO3 8 into whatever the atomic masses add and find 63 is the molecular mass. 8 into 63 you do 504 grams. Then for volume, again what you will take? Molar volume. So 2 into 22.4 liter will give you 44.8 liter. So therefore, you can find first one. 504 gram of HNO3 gives 192 gram of copper. Therefore, 63 gram of HNO3 gives, simple. Here I have also written the units of what we are taking here. 192 gram of copper into 63 gram of HNO3 divided by 504 gram of HNO3. So try to write like this, practice this, so that you can cancel out what is common and what is left. Automatically you will write it. Sometimes you will forget, you'll just write 24. You will forget to write grams, or you'll forget to write 24 grams of copper. So if you follow this, practice this, you will not miss that. Similarly, for second one, you will simply do 504 gram of HNO3 gives 44.8 liter of NO. Therefore, 63 gives how much? So when you solve that, again I have taken here 44.8 liter of NO into 63 gram of HNO3 divided by 504 gram of HNO3. So here gram of HNO3 cancel out. What is left? Only liter of NO. So you will not forget that 5.6 liter of NO will be the answer. Fourth question. Zinc blood ZNS. Pause the video, read. Try to solve it yourself, then come back. So let's write balanced equation. They have not given. Roasting we learned in the metallurgy. Roasting is nothing but converting it into metallic oxide in presence of air. Means mainly oxygen is required. ZnS plus O2 will give you ZnO plus SO2 will be the byproduct. So first skeleton equation, then you balance it, you will get this balanced equation. Balancing, if you do wrong, everything will be wrong. Next, what is they have asked? A, for 776 gram of ZnS, what is the number of moles of SO2 you are getting? B, for 22.4 liter of SO2 at STP, what is the mass of ZnS will be required? So first you find the molecular weight of ZnS. Here below only you can write, or here I am writing it separately. 65.32 means and 97 you are getting. Volume of SO2 at STP is 22.4 liter, that we already know. To find A, moles for 776, since 2 into 97 gram of ZnS gives 2 moles of SO2, right? Moles and moles, right? 776 gram of ZnS gives how much? So I have written here, you can see 2 moles SO2 into 776 gram ZnS divided by 2 into 97 gram ZnS. Gram ZnS cancel out. What is left? Moles SO2. Numbers you have to remove. Okay, 2 cancel. Whatever left, 776 by 97, if you do, you'll get 8 moles of SO2. Similarly, for B, 1 mole SO2 found by 1 mole ZnS, right? Therefore, 22.4 liter of SO2 means 1 mole and 97 gram of ZnS means 1 mole of ZnS. Therefore, to form 22.4 liter, you need mass of ZnS as 97 gram. This is another way. You can also get, all the calculation thing, but mole to mole you can also find it. Okay. Fifth question. Read the question. Ammonia react with sulfuric acid to give fertilizer ammonium sulfate. Means ammonia and sulfuric acid are the reactants. Ammonium sulfate is the product. First, write balanced equation. So I have written here. What is asked? To form 59 gram of ammonium sulfate, what is the volume of ammonia you need? Okay. So again, ammonia is a gas. So 2 into 22.4 liter at STP will give you, find the molecular mass of ammonium sulfate, 132 gram, right? So 44.8 here. Since 132 gram of ammonium sulfate needs 44.8 liter of ammonia, 59 gram of ammonium sulfate needs how much? So again I have written liter of ammonia, gram of ammonium sulfate, which will cancel out. So final whatever answer you get, that will be liter of ammonia. So it is 20.02 liter of ammonia. Okay. Heat on lead nitrate gives yellow lead oxide, lead 2 oxide and nitrogen dioxide oxygen. So everything is given. Lead nitrate is the reactant, lead oxide, nitrogen dioxide and oxygen, they are products. So first write balanced equation. So for this particular reaction, instead of lead, it may be zinc, it may be calcium. For all, you remember 2, 2, 4, 1. The coefficients, if you write in this order, 2, 2, 4, 1, it will save your time if you remember it. What is asked? For 8.5 gram of lead nitrate, what is the total volume of NO2 and O2 you are getting? Total volume, not individual. So first you find the molecular mass of lead nitrate and multiply it by 2. So for 662 gram, what is the total volume you are getting? 4 plus 1. Both are gases, right? 4 plus 1 is 5. 5 into 22.4 means for 662 gram, you will get 5 into 22.4 liters of total NO2 plus O2. Therefore, for 8.5 gram, how much you will get? So I've written everything here. Solve it, cancel out these grams of lead nitrate. So whatever final answer you get, 1.43 liter, that will be total volume of NO2 and O2. Total volume. Okay. Yeah. Here, very interesting. Read slowly. they have given two equations, KClO3, C plus O2, CO2. They have asked calculate the amount of KClO3, that should be your final answer, which on thermal decomposition gives X volume of oxygen. So they have not given volume of oxygen, you have to find X. How do you find? Using the second equation, which is the volume required for combustion of 24 gram of carbon. Okay, very simple. First, find X, volume of oxygen. From which? From the second equation, C plus O2, CO2. So simple, 12 gram of carbon if you take, you will get 22.4 liter of oxygen gas, molar volume, right? So for 24 gram, how much? Double, 44.8 liter. Therefore, you found X as 44.8 liter. So now, next you have to find the mass of potassium chlorate using the second equation. What is the mass for 44.8 liter? Molecular mass of potassium chloride you find, it is 122.5. So therefore, since 3 moles oxygen means 3 into 22.4 liter of oxygen if you take, you will get or you will need 2 into 122.5 gram of potassium chloride, right? Therefore, to form 44.8 liter of oxygen, how much you need? So again, it is given in detail here. Gram potassium chlorate, liter of oxygen will get cancelled. So final answer will be 163.33 gram of potassium chlorate. So very simple. Second, calculate the weight of ammonia, weight, not the volume, remember, required for reacting. A. Similar question solved in question number 5 for volume. So you can just do the same thing to find the weight. There I have taken volume of ammonia, you just find the molecular mass, which is 17, and just find it. Okay. Again, what is that? Ammonia gas plus sulfuric acid give you ammonium sulfate. That is the same equation. Second one, B. Weight of ammonia gas obtained when 32.6 gram of ammonium chloride reacts with calcium hydroxide during the high laboratory preparation of ammonia. So equation already given. So let's take that second one, B. Balanced equation already given, write it. They have asked what is the mass of ammonia for 32.6 gram of ammonium chloride. Same, again find ammonium chloride molecular mass and multiply it by 2, 107 gram. So for 107 gram, you should get ammonia how much? 2 into 17, 34, right? Same. Since 107 gram of ammonium chloride gives 34 gram, 32.6 gram of ammonium chloride gives how much? So gram ammonium chloride will get cancelled here, gram ammonium chloride. So whatever left is gram of ammonia gas. It is 10.35 grams. Ninth question. Sodium carbonate reacts with dilute sulfuric acid, salt, water and carbon dioxide will be given. Calculate the mass of pure salt formed when 300 gram of sodium carbonate of 80% purity reacts with dilute sulfuric acid. When you read it, you may think it is difficult, but it's very simple. First, let's write the balanced equation. Reactants are sodium carbonate and sulfuric acid. Product will be salt. Salt is sodium sulfate plus H2O plus CO2. So it's already balanced. What is asked? If you take 300 gram of 80% pure sodium carbonate, what is the mass of sodium sulfate you are getting? That is the salt you are getting, right? So first find for 100% how much you are getting. Later we'll take 300 gram. So you'll find molecular mass of sodium carbonate 106, for sodium sulfate 142. Okay. Since 106 gram of 100% pure sodium carbonate gives 142 gram of sodium sulfate, therefore 300 gram of 80% purity means 300 into 80%. It will be 240 gram. Therefore, 240 gram of pure sodium carbonate gives how much? That's it. Okay, 142 into 240 by 106. You will get 321.5 gram of sodium sulfate salt. Okay, this point is important to understand. 10th question. Again, sulfur burns in oxygen to give sulfur dioxide. 16 gram of sulfur burns in X cc of oxygen. Calculate the amount of potassium nitrate which must be heated to produce X cc. Again, two are there, like we did previously one example. Two equations are necessary. First one, sulfur plus oxygen give you sulfur dioxide. From equation, it's already balanced. For 16 gram, how much you need? So we know 32 gram of sulfur needs 22.4 liter, or you just change it into cc, 22,400 cc it will become. Therefore 16 gram is half, that is 11.2 liter or 11,200 cc. So now you found x, then go to the second equation, potassium nitrate. Here potassium nitrate on decomposition they have given, they will give oxygen, but what is one more product? You should know that potassium nitrate and sodium nitrate will give you respective nitrites plus oxygen. But if you take lead nitrate, calcium and zinc nitrate, they will also give you what? Nitrogen dioxide along with the metal oxide. They will not give you nitrite. Okay, what is asked here? 11.2 liter or 11,200 cc. What is the mass of potassium nitrate? So same molecular weight of potassium nitrate 101. So 22.4 liter is formed by 101. Therefore, sorry, 2 times 101 because 2 is there. Therefore, 11.2 liter will be formed from how much? So it's already solved. You will get 101 gram of potassium nitrate will be needed. Or moles, 2:1 ratio, right? So for half of this, you will get 1 mole of this. 1 mole is nothing but whatever its molecular mass, 101 gram. Next question, read it. Sample of impure magnesium, dilute sulfuric acid, salt and hydrogen. If you take 1 gram impure sample, it give 298.6 hydrogen. Calculate the percentage purity. Okay, this is a different kind of question. Percentage purity is asked. Let's write the balanced equation. Magnesium plus sulfuric acid gives you magnesium sulfate plus hydrogen. So they have given 24 gram. No, if you take 24 gram, you will get 22.4 liter. So for 1 gram pure sample, if you take 1 gram pure magnesium, it should give you, calculate from this, 0.9333 liter or 933.3 cc. But they have given for impure, it is giving 298, right? So percentage purity, how do we find? Percentage purity will be whatever actual yield you have got divided by expected yield. So expected yield means expected is 933.3 cc, actually got 298.6 cc. Into 100 if you do, you will get 31.99%. That is the purity of this magnesium. So this is the last question of this. Okay, so hope you understood and it is helpful. Thank you so much for your time. Take care. Bye bye.